These are notes for 5.7 part 1, and this section is just called general factoring strategies. So what we're going to start doing is we're not going to just be given a bunch of problems that are all one type of factoring. We're just going to get a problem. We're going to have to figure out how should we factor this problem. So let's first write out a general strategy that we can take, and it's going to kind of be a chart that spans the whole width of your page. So no matter what kind of problem you're given, if you are factoring, so you're breaking it up into its factors, the first step you always want to take is to factor out common factors. Now, you won't always be able to do that, so this is just if possible. So whenever you guys ask me a question, I'm coming around, a lot of the time I say, can you take something out of everything? So that means, is there one number that you can divide out of all those terms that might lead you to a better factoring strategy? So you always want to do that first, no matter what. Then, after you factor out a common factor, if you can, you want to look at how many terms there are. So if you're left with a polynomial that has two terms, there's two different things we can look for. If you're just left with two terms, first of all, you might not be able to factor anymore after you take out that common factor, but you want to check for two things. So the first one you want to check for is a difference of squares. So remember, I'm going to write what that looks like. That's when we have something like a squared, a perfect square, minus another perfect square. And that turns into a plus b times a minus b. So that's a difference of squares. The second thing that it might be, if it's a two-term polynomial, is it could be a sum or difference of cubes. And that was what our last note section was on. So a sum of cubes looks like this, a cubed plus b cubed. And we factor that into a plus b times a squared minus ab plus b squared. And a difference of cubes, a cubed minus b cubed, we just factor that into a minus b times a squared plus ab plus b squared. You're supposed to have those memorized. So those are the two things that could happen if you are left with two terms. So then let's look at, I'm going to have to really stretch to make this fit here. So I'm going to kind of, on my paper, what I did is I went like way down below this whole section to give myself some room. And we're going to do 3 terms right here, and then we'll leave that upper right corner for 4 terms. So if you have something with 3 terms, you kind of have 3 choices for what could happen here. One thing that might happen that you want to look for first is a perfect square trinomial. That's where your first and your last terms are perfect squares, and your middle term is double the square root of those first and last terms. So that is where you have something like something squared plus or minus 2 times ab plus b squared, and that factors into a plus or minus whatever it was in the beginning. That plus or minus is what it stays. Whoops. That just goes into a plus or minus b all squared. So you could have a perfect square trinomial. The second thing you might have is just kind of I just consider this regular factoring. Something like x squared plus something x plus a constant. Like x squared plus 5x plus 6. That could be one. And if you see that, that's where you just look for two numbers that multiply to c and add to b. There's not really like a formula way of writing that. You just look for the numbers that multiply to c and add to b, and you put those in your parentheses. And then the third thing that could happen is you have the same thing, but there's that number in front of x squared, that a right there. So if that happens, and you have something x squared plus bx plus c, remember, you have to put that in order first maybe. That's where you want to use the AC method. Try that out. Remember, you might have to try more than one of these things before you find something that works. And then last, I'm going to go back up in that spot up there in the upper right, and we're going to look at what if you had something that was 4 or more terms. So what you want to do then is your first thing you might want to look at is factoring by grouping. Now that's only going to work if you have an even number of terms. And then the second thing, and I think this is honestly the toughest thing to see, this is really like a challenge problem, is you might need to split the problem up into a difference of squares or a perfect square trinomial or something like that. And I'll look at a couple like that. I think those are the toughest ones. So you're going to do one of those three things, whether it has 2 terms, 3 terms, 4 more terms. Then the last thing you want to do is check all of your factors. So check if any of your factors can be factored anymore. Because a lot of times you guys are leaving on tests and things something that could be factored, like you could pull something out of it. So you have to factor everything as much as you possibly can. So this is like your big chart. Here's how to factor things in general. You might have to try more than one strategy though. This is not straightforward, guys. You've got to try different things here. So let's try some examples. So all these are just going to say factor. So that means like it's multiplied out, you've got to unmultiply it. You've got to factor it. So we're going to try factoring 10a squared x minus 40b squared x. So think about what your first step is right here. Look back up at what our first step is. Right now, we can factor something out of both of those terms, right? I can factor a 10 out of both of those numbers. And I can take an x away from both those terms. So I'm going to factor out 10x. I'm left with a squared minus 4b squared. I divided each of the numbers by 10, and I took the x away from each of those terms. That's how I got what was in there. Now, I want to look at those parentheses and see if I can factor any more. So when I see just 2 terms, I'm thinking, I wonder if this is either a difference of squares or a difference of cubes. I know it's a difference because it's a minus. And when I see the 4 and the 2 things squared in there, I recognize, hey, this thing in the parentheses, this is a difference of squares. So I'm going to try and rewrite it. I got my 10x sitting out here. Don't forget to bring that guy down. This is really a squared minus 2b squared. So I rewrote what was in the parentheses as 2 things squared. So I kind of broke it down to the square roots of each of those things. So if you remember your difference of square rule, keep that 10x on the outside. Remember, a difference of squares is when you have something squared minus something squared, and it breaks down into the somethings minus each other and the somethings added to each other. So these are going to break down into a plus 2b times a minus 2b. And that's just something you'd have to know. Like, you just have to know, oh, it's a difference of squares. That's how I factor a difference of squares. I look at all those. I can't factor anything else out. So we're good. That's it. When I'm looking at the way I kind of know that I can't factor these anymore is partially because there's no number I can take out of both of those terms, and all the exponents are 1 on all the letters. Like, it's just A, it's just B. There's no B squared or anything. As soon as I get to that point, I know I can't factor it anymore. All right, let's try 1, 2, 3 more, and then I'm going to give you 2 to try. So we are going to factor x to the 6 minus 64. So first I check for, can I factor something out of everything? No, can't take anything out. So then we want to look for how many terms. It has 2 terms. I'm looking at my chart that we first wrote down. And if it has 2 terms, the first thing I want to look for is, can I write that as a difference of squares? And I think that I can. I could also write it as a difference of cubes, but remember, you want to do difference of squares first if you can. So let's rewrite this as this is x cubed squared, because 3 times 2 would get me back to 6, minus 64 is the same as 8 squared. So this is a difference of squares, same as we just did. So if I break this down, it's going to break into x to the 3 plus 8 times x to the 3 minus 8. I'm going to write actually one of these in green because we're going to be able to factor it more. I want to show you that. So now I'm broken down into two factors, and I want to check, can I factor either of these anymore? They're both two terms. They're not squares, and this one's definitely not a difference of squares because it's not even a difference, it's a plus. This other one right here, the green guy, he's not a difference of squares because it's a difference, but 8 is not a perfect square. But if you remember your cubes, remember that 2 cubed equals 8. So both of these are a sum and difference of cubes. So this first one is a sum of cubes, and the second one's a difference of cubes. Let's go ahead and factor this first one. This is x to the power of 3, and 8 is 2 to the power of 3. So this is like my a and my b. So I'm looking at my front and my little formula for sum of cubes, which we hopefully memorized by now. And this is going to break into x plus 2 times x squared minus 2x plus 4. I got the 4 because that's 2 squared. That's my b squared. Now let's factor the green one. That's a difference of cubes. So this is x cubed and 2 cubed. So this is going to become x minus 2, because on a difference of cubes I have a minus in the beginning. And then x squared plus 2x plus 4. The 4 came from 2 squared because you square b, and b is 2. This is a, this is b. So I'm just using that formula. Now I could check, can I factor any of these anymore? This guy, no, there's nothing I can take out of everything. There's only a power of 1. This guy, does anything multiply to positive 4 and add to negative 2? No, can't do it anymore. Happens for all of them. Can't factor them anymore. But you have to check. You have to look, can I factor those anymore? The answer on this one is no, so we're done. All right, 2 more examples and 2 to try on your own. We're going to factor 7x to the 6th plus 35y squared. All right, first step, can we factor anything out of both of those terms? Well, 7 and 35 are both divisible by 7, so I can take out a 7. The first term has all x's, the second term has all y's, so I can't take any variables out. So I'm just left with x to the 6th plus y squared. So now we want to look in these parentheses. It has 2 terms, so I'm looking for, is it a difference of squares? Well, no, it's not a difference of squares because there's a plus. That's not a difference, that's a sum. Is it a sum of cubes? No, because we can't write y squared as a cube. So that's it. I'm done. And that's kind of tricky. You have to just be confident and know when to stop. So that's what you're going to have to know, like, can I factor this anymore or can I not? You're going to get really good at recognizing it. All right, we got one more to do together. We're going to factor 2x squared plus 50a squared minus 20ax. So first, let's see, is there something we can factor out of all 3 of those terms? We can't take any letters out because they don't all have an a and an x. But we could divide all those numbers by 2, right? So let's take a 2 out. I'm left with x squared plus 25a squared minus 10ax. So now we want to see if we can factor this guy anymore. One thing I know that kind of makes it easier to look at is we want our x's to be in descending order when it comes to their powers. Right now it's not. I've got the squared here, then I go down to the 1 over here, and finally no x's here. So we're going to reorder this with the x's in descending power. So I'm going to keep the 2 on the outside. I'm going to have x squared. I'm going to move the minus 10ax there. and then the plus 25a squared. So from here to here, all I did was reorder it to make my x's go in descending order of power. Now, let's look at that guy in the parentheses. It has 3 terms. So let's first check if it's a perfect square trinomial. That's on our chart in the beginning. If it has 3 terms, first we should check, is it a perfect square trinomial? So to check for that, we want to see, are the first and the last term something squared? Well, yeah, the first term is just x squared. That's x squared. The last term is, let me do this one in blue. The last term is, 5a times 5a would get me 25a squared. So now we want to check the middle term. Since it's negative, we're going to check if it's negative 2, and the 2, you just have to remember that. Is it negative 2 times my x times my 5a? I'm trying to do those color-coded so you know where I got them from. X, 5a. Well, let's see. Negative 2 times x times 5a, that is negative 10ax, and that's my middle term right here. So, yay, it is a perfect square trinomial. So, to factor a perfect square trinomial, that's going to factor into x minus, because of that minus, 5a all squared. And remember that I had that 2 out front. Don't forget him. That's it. Can't factor what's in those parentheses anymore for sure. So I'm going to give you guys 2 to try on your own. I want you to try those and then come to class with questions tomorrow, and we will practice lots of these. So go ahead and try factoring 64a to the 6th minus 1 and 4y squared plus 28y plus 49. So your instructions on these is just factor. All right, see you with questions.